Our Chapter 2 and 3 practice test is going to start with this problem, and where all of this information we're going to use for the first three problems. So we have Steve playing a ball toss game. He's at a starting point and throwing a ball 4 feet away into a basket. It says that the height of the ball is the perpendicular distance from the ground. It's a function of the horizontal distance from the starting point. So this table is going to give us the information that we need, and we can use this graph to help us. So what we're going to do is we're going to plot these points and label the axes. So given that in the table it's x and y, that can help you to label your x-axis as the distance from the starting point in feet, and y is going to be your height, also in feet. Okay, so we're going to plot the points. So 2, 0, x, y would put us here. And then 3, 3, 4, 4, 5, 3, 5.5, 1.7 would be about right here. And then 6, 0. So if we drew our graph through those points, we kind of see a parabola is given to us with this table and these points. So the first question is asking if the initial height is the same height as 5 feet from the starting point. So if we look at this, this is our initial height right here. Our initial height is 0. Because that's where he's first starting. And then the 5 feet away from the starting point puts us here. And that is at a height of 3 feet. So to answer the question, the initial height is not the same as 5 feet away. 0 feet compared to 3 feet, they're not the same. So my answer is false. The highest point reached by the ball was 4 feet. So if we look here, we can see the highest point in the graph would be here. And that would be at the ordered pair 4, 4. Or we could see that the height is 4 feet. So our highest point is in fact 4 feet. So we will say true. And then the third question is asking if the height of the ball increased from when the ball was at a distance of 2 feet from the starting point to a distance of 4 feet from the starting point. So this is our distance from the starting point. If we go to 2 feet from the starting point, that will be right here. So 2 feet from the starting point. And then we're going to look at to 4 feet from the starting point would be from this point to this point. And if we do look between those two, we do see that the graph is going up. So the graph is increasing. So that is true. Between 2 and 4 feet, it is going up. So we would say true, it is increasing, or it did increase. All right, so now we're going on to number 4. Which no longer uses that information. So we're looking at which of the following graphs represents a vertical stretch of this equation. So y equals x plus 6 squared minus 5. What we're looking for a vertical stretch is an a value that is greater than what they give us in this original equation. So when they give us the original equation, we have an a value of 1. So my a value is 1 here in my original function. So I'm looking for an a value that's greater than 1. So remember, the a value, if this is vertex form, which all of these equations are in vertex form, remember this is our setup. This is the formula. The a value is the number out in front. So we're looking for that number out in front that's greater than 1. So this is 1, which is equal to 1, so that's not what we're looking for. 7/5 is our answer because 7/5 is a number greater than 1. It's an improper fraction, meaning if 5 was one whole, picture 5 as 5 slices of pizza to make one whole pizza. So out of 5 slices, you have 7 slices, which means you have more than one whole pizza. So you have more than one. So B would be our answer for a vertical stretch. C is not our answer because 5/7 is a fraction less than 1, which actually makes it a vertical shrink. So that's not what we would want to choose. And then it's not D. Okay, number 5, which is a factor of x squared plus 3x minus 18. What we're going to do is just factor this trinomial. So we look at two terms that multiply to give us x squared. It'll be x and x. Two terms that multiply to give you 18. We'll do 6 and 3. And then we remember our procedure. You take this middle term, and we're going to write it here underneath. And then we're going to multiply diagonally. X times 6 is 6x. X times 3 is 3x. And then we need to figure out what signs these need to be to give us positive 3. So for that, we would have to have a positive 6 and negative 3. So you carry over the signs. That's positive, this is negative, and your factors are x plus 6, x minus 3. So it's asking which is a factor, meaning we're just going to have one answer. So you don't see x minus 3, but you do see x plus 6. So C is our answer. Okay, number 6 is asking us what are the solutions for the quadratic equations. So I am going to talk to you about all the different methods we've talked about for solving. So we're just going to take note of this. All of the different methods we have for solving the quadratic equation. We talked first about graphing. We talked about factoring, using square roots, completing the square, and quadratic formula. So these are all different methods that we have for solving. Okay, but we want to remember solving using square roots is an exception. This one you can only you only want to use if you have x squared only, meaning you don't have an x term. So if you look, what I mean here is we have an x squared and an x term, which means for this type of information given to us, we wouldn't use the square roots method, solving using square roots. But what we would want to do out of these four, graphing is by far the easiest. So we always want to try the graphing method, or not graphing, I'm sorry you guys, wow, I'm already making mistakes. Graphing method is probably the most involved, that's actually the hardest. The factoring method is what I meant to circle. The factoring method is the easiest, so that's what you always want to try first when they ask you to solve. So what are the solutions is asking us to solve this. So to use the factoring method, we're not ready yet. This -6 needs to move to the other side because we need all of our terms on one side of the equal sign. So what I'm going to do is I'm going to move this over by doing the inverse operation. I'm going to add 6 to both sides of my equal sign. And then I'm rewriting this left side as x squared minus 5x plus 6 equals 0 because those cancel. So now I'm going to do my factoring method. My factoring method is going to, we're looking at what two terms multiply to give us x squared. It's going to be x and x. What two terms multiply to give us 6 that are going to add up to -5x. So we have different options. If you chose 6 and 1, you would have to have different signs to get to 5. And we can't have different signs because my answer or my constant is positive. So we want to use 2 and 3. So x times 2 is going to give us 2x. X times 3 when I multiply diagonally is 3x, and both of these signs need to be negative in order to get to -5x. So my factors I'll rewrite over here are x minus 2 and x minus 3. So again, the -2 times the -3 gives you the +6, and so we can check our work a little bit that way. So when you have your factors, when you're solving using the factoring method, you then take each of your factors and set them equal to 0. After you set each factor equal to 0, you solve. So we get x equals 2 as our first solution, and x equals 3 is going to be our second solution. So we have 2 and 3. Number 7, the graph below is going to show a grade for math homework. They're asking us what the homework grade would be if you complete 20 assignments. So all we need to do for this problem is know how to read the graph. So I'm looking for the grade for 20 completed assignments. The completed assignments are on the x-axis. So what I'm going to do is I'm going to go to 20. And then I'm going to figure out where is that going to be for my homework grade. So they actually have an ordered pair there already for us. So for 20 completed assignments, your percentage is going to be 95% because that lies right here on my line at 20, 95. So just reading the graph on that question. All right, number 8, we are solving this equation by completing the square. So that is going to be the method we use. What number should be added to both sides of the equation to complete the square? Okay, so they're not asking us to solve. They just want to know what number we add to both sides. So for our completing the square method, we do have to memorize b divided by 2 squared. That is the formula that gets that number for you that you add to both sides. So our b from this given equation is -6. So I'm going to plug that into my formula. -6 divided by 2 squared. Remember, order of operations, you would do your division inside the parentheses and then square. So dividing -6 divided by 2, we get -3. And then -3 squared is 9. So to complete the square, we would add 9 to both sides of the equation. So my answer is A. Number 9 is asking us what are the x-intercepts. So we have to remember, when they ask us what are the x-intercepts, they're asking us for the solutions, because we have to remember that the x-intercepts when we graph, so this is just a pretend graph, your x-intercepts, you guys, are called the solutions, okay? So x-intercepts are solutions. So they're telling us that we need to solve. So let me just get that out of the way. I don't want anyone to get confused. We're going to solve this. And again, we talked about up here all the different methods we have for solving. We're not solving using square roots because we have x squared and x terms. So again, the easiest method is factoring. We should try factoring first. So when I factor, I can try 4 and 1 or 2 and 2. I'm going to go ahead and do 2 and 2. And then 2 numbers to get to 5 that are going to add up to 12x. I'm going to go ahead and pick 5 and 1. So when I multiply diagonally, 2x times 5 is 10x. 2x times 1 is 2x. And these would both need to be positive to add up to the positive 12x for that middle term. So I carry over the positive, carry over that positive. My factors are 2x plus 5 and 2x plus 1. And then again, with your factoring method, you take each of your factors and you set them equal to 0. And then solve. So I subtract 5. 2x is -5. Divide by 2. X is equal to -5 halves. That's going to be our first answer. And then subtracting 1. 2x is equal to -1. Divide by 2, x is equal to -1 half. So my answers are -5 halves and -1 half. Those are my x-intercepts or my solutions. Again, your solutions are where your parabola crosses the x-axis. That's why they're called x-intercepts. Okay, number 10, we want the graph for y equals -2 times the quantity x minus 3 squared plus 2. So anytime we graph, we always want to, given vertex form, make a table with 5 values so we can get a nice accurate graph. So remember, for the middle of your table, you're always going to put the vertex. Let me zoom out a little bit here. You always put the vertex in the middle. So first thing we want to identify is the vertex. They call this vertex form because h and k for our vertex are given to us. We just have to remember that you always change the sign when you pull out h or x for your vertex. So this is going to be positive 3, and then we just copy down that number. 3, 2 is our vertex. So we're going to put that in the middle of our table. We can actually already eliminate some of these answers because 3, 2, our answer can't be this. 3, 2 is over here, so our answer cannot be this. Okay, so you can actually find your answer already, but I am going to show you the table, and then we'll talk about how to go ahead and pick your answer without doing the work. So with the table, you complete the side with x by subtracting 1 and subtracting 1 again. Complete this bottom part by adding 1 and adding 1 again. So with the table, I'm only going to plug in half. I'm going to plug in just the top 2 values because with a symmetric U-shaped parabola, those same values will go down here for 4 and 5. So when x is equal to 1, I'm going to plug that into my equation so I can find y. I have negative 2 times 1 minus 3 squared plus 2. Again, I'm just replacing x with 1 in my original equation. So I have negative 2 times the quantity negative 2 squared plus 2. Order of operation says I need to square the negative 2 first. So I get negative 2 squared is 4. And then multiply. And then add, and I get negative 6. So negative 6 is going to be my y value for 1. And then when you plug in 2, it's going to be y equals negative 2 times 2 minus 3 squared plus 2, again plugging in 2 to my original equation up here. So parentheses, I get negative 1, copy down the rest. Exponent, negative 1 squared is 1. And then multiply, and then add, we get 0. So to complete our table, we put a 0 here. Because I'm 1 to the left, it's going to be the same number as 1 to the right. 2 to the left will be the same as 2 to the right. So I want to find the graph that is consistent with this table. So we have over here 3, 2, but then we need 4, 0 and 2, 0. So D is not going to be my answer. My graph is over here. And then negative 6, so A. And so a way we could have just looked at our multiple choice answers would have been first looking at the vertex, which we determined C and B are not going to be our answers. But also the negative A value tells you that this is going to open upside down. This is going to open down. So that in that case, knowing that, I could have just chosen A without doing this work, but I felt like doing this work wouldn't hurt, and it's good practice for definitely our open-ended question or questions, more than one. Okay, number 11, they're asking what is the product of these numbers. So we want to remember that product means you're going to multiply the numbers. So we're going to multiply these complex numbers. It's going to be 10 plus 4i times 10 minus 13i. So what we're going to do is we're first going to distribute the 10 into parentheses over here, then we're going to distribute the 4i into parentheses so we can get 4 terms. So we get 10 times 10 is 100. 10 times negative 13i is negative 130i. 4i times 10 is positive 40i. And 4i times negative 13 is negative 52i squared. But for those of you who can't do it in your head, which is fine, I didn't when I was your age, 3 times 4 is 12. Carry the 1. 4 times 1 is 1 plus 1 is 5. So that's how you get 52, showing your work on the side. So it was a positive times a negative. That's how we got negative. And then I times I gave us the I squared. So what we're going to do now is we're going to simplify. When I go through and simplify, I have to remember that I squared equals negative 1. So that is something that we are going to have to memorize if we don't have it memorized yet. So we're going to keep the 100. Negative 130 plus 40 is going to give us negative 90i. And then negative 52, and I'm going to replace I squared with negative 1. And then I'm going to continue to simplify. Negative 52 times negative 1 is positive 52. And then combining, I get 152 minus 90i. So again, the I squared actually makes that term a real number because it throws out I. Because I squared just means negative 1, it means take that coefficient, make it a constant by changing the sign. And then you combine like terms. There's your answer. Number 12, we're going to graph this function. So when we graph, we are going to look at our x-intercepts first. Because this is an intercept form, think of it like solving. To solve these, I would set this equal to 0, I'd set this equal to 0, and get 3 and negative 1 as my answers. That's why those are my x-intercepts. Or you can just remember the p and q, where p is your first x-intercept. You just take that number and change the sign, got positive 3. Q is going to be from this parentheses, you just take out the number and change the sign. So my x-intercepts are 3 and negative 1. So far this graph looks good. 3 and negative 1 also happens in part B, but I'm going to cross out C and D because it's not negative 3 and positive 1. All right, so I know those are my x-intercepts. The next thing I want to do, and the final thing I need to do, is figure out the vertex. So to figure out the vertex, you can do the formula p plus q, x equals p plus q divided by 2. So it's 3 plus negative 1 divided by 2. 2 divided by 2 equals 1. Or you can simply look at your graph, and what you do is you look for that directly middle between the two x-intercepts. So 1, 2, 1, 2. Just by counting my x-intercepts, I know that x equals 1 will be right in the middle because of my line of symmetry. And the vertex goes through, or your line of symmetry goes through the vertex. So x is equal to 1. Using the formula or just counting boxes and seeing 1 is right in the middle of those two x-intercepts. So we have the x value, and just like what we've been talking about in this entire chapter is anytime you have the x value, you plug it into your equation to get the y value. So I'm plugging it in, 1 minus 3 times 1 plus 1. And then I'm going to simplify in my parentheses, negative 2 and 2. Parentheses, when they're right next to each other, mean multiply. So negative 2 times 2 is negative 4. My vertex is 1, negative 4, not 1, positive 4. So my answer is not going to be A, but my answer is going to be B, which has a vertex at 1, negative 4. Also, this graph had a positive A value. It was a positive 1 out in front. So I knew that the graph should be positive opening up, like B. Number 13, we have this graph given to us for x squared plus x equals 6. And they are asking us for what value or values of x is y equals 0. So there are a couple ways we can do this. We can solve algebraically, or we can go ahead and just look at the graph. So what I'm going to do is I'm going to graph y equals 0. When I graph y equals 0, it's going to be a horizontal line at 0. So graphing y equals 0 looks like this. That's y equals 0. So now what I'm going to do is I'm going to look to see what values on my graph are at y equals 0. So what of these values of x are y equals 0? So what you do is you just look to see where they intersect at negative 5 and positive, or I'm sorry, negative 3 and positive 2 is where they intersect. So that's one way you could do it. I think that might be the easiest way for us, drawing the line and then looking where they intersect. So it's negative 3 and positive 2. So D is my answer. Okay, which ordered pair is the vertex? So vertex, we remember in a parabola for our graph is going to be that very low point for the minimum or the very high point for the maximum. So This is going to be an ordered pair. Remember, it's an ordered pair, x comma y. So in order to find x, you have to memorize x is equal to negative b over 2a. That is how you are going to always find the vertex, given standard form like this. So b is 20 and a is negative 5. So I'm going to take those and plug them into my formula. Negative b would change this positive 20 and make it a negative 20 over 2 times a, and a is negative 5. So I just plug in. So that's negative 20 over negative 10 to give us positive 2. So now again, to find your y, you take the x and you plug it in for x and x again for my formula. So y is equal to negative 5 times 2 squared plus 20 times 2 minus 9. Order of operations, we're going to square the 2 first. So I get negative 5 times 4, and I'm going to copy down the rest. Then I'm going to multiply. Negative 5 times 4 is negative 20. 20 times 2 is 40, minus 9. Negative 20 plus 40 is positive 20. 20 minus 9 is 11. So my vertex is 2, 11. Okay, number 15. We're going to find the length of the longest side of this rectangle, given that the perimeter is 44, and they give us already the length of the sides. So some of you are going to use this formula, 2 times the length plus 2 times the width is equal to your perimeter, but I'm going to go ahead and just write it all out without having to memorize another formula, for those of you who don't have that memorized. So because this is 7x minus 3, then this side length is also 7x minus 3. Because this is 3x minus 5, this is 3x minus 5, because in geometry we learned that a rectangle, the opposite sides are going to be the same or congruent. So with this, perimeter means we're going to add up all these sides, and then we know the perimeter is 144. So after we added them all, we're going to set it equal to 144. So I'm going to rewrite each of these. It's going to be 7x minus 3 plus 3x minus 5 plus 7x minus 3 plus 3x minus 5. Again, none of that order matters. We're just adding everything. We're setting it equal to 144 because they tell us the perimeter is 144. So what we do now is we go through and we combine like terms. 7x and 3x is 10, 17, 20. So we have 20x. Then combining our constants, negative 3 and negative 5 is negative 8, negative 11, negative 16. And that's equal to 144. So now I'm going to solve for x by doing our inverse operations, adding 16. I get 20x is equal to 160. And then final step for x, divide by 20. 160 divided by 20 gives us 8. So hopefully you're not going to go and circle 8. Your answer is not 8 because that's not what they're asking us to find. They're asking us for the length of the longest side. So we're not done once we get x. We're going to take x, we're going to plug it in for the longest side. So 7x minus 3. You just replace the x with 8. 56 minus 3 is 53. My answer is A. Okay. How many times does the graph intersect the x-axis? They're asking us for the number of x-intercepts. They're not asking us what are the x-intercepts. We just want to know how many times. So that's our discriminant, b squared minus 4ac. And again, you guys, that actually comes from the quadratic formula. Those of you in my class, we talked about that. In the quadratic formula, that's where this comes from, underneath the square root. And that has to do with why we get 1, 2, or no answers. So from our equation, a is 3, b is negative 1, and c is 3. And I take those and I plug them in. So b is negative 1, so I have negative 1 squared, minus 4 times 3 times 3. And then I just simplify this. Negative 1 squared is positive 1. Negative 4 times 3 is negative 12. And negative 12 times 3 is negative 36. So minus 36. 1 minus 36 is negative 35. Because I got a negative answer, that means that I have now an imaginary answer. So there's no real solutions, or this does not cross the x-axis. So negative means there are no x-intercepts. Okay, we're going to find the solutions. So again, you can't complete the square. You're not trying to isolate x because there's an x squared and an x term. If we tried to factor this, because that is our easiest method, you wouldn't come up with something to factor. It wouldn't work to add up to -1. So you're not going to do your factoring method. Plus, these numbers are not nice numbers. They have the radicals, so the factoring method, you can see then, doesn't work. So I am going to use the quadratic formula. So I'm going to write that for you. The quadratic formula is x is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to plug in a, b, and c from this equation. So from here, we have a equals 5, b equals -1, and c is equal to -4. So I take all those numbers, plug them in. Opposite b, or negative b, means now +1 instead of -1, plus or minus the square root of b squared, so -1 squared, minus 4 times a times c, all over 2 times a. And then I would just go through and simplify in my radical, or in my square root. 1 plus or minus, -1 squared is +1. -4 times 5 is -20. -20 times -4 is a +80. Because I have two negatives, when I multiply, it becomes +80. All over 10. So then I'm going to have 1 plus or minus square root of 81 over 10. Oh, this is actually, okay, this is interesting. They're going to separate this for us. And we get this as our answer. So I lied. This actually would have been factorable. It would have worked with 1 and 4. But anyways, that doesn't matter. Based on these answers, they wanted us to use the quadratic formula. Although we can simplify this further, this is the answer that we're looking for, part C. Okay, we're going to write the equation of this function. So I know if you have my practice test and my class, B and C look a little different, but that's okay. You can still follow along to see how we come up with the answer. So if I'm writing an equation of this function, I am going to use my vertex formula. Because they give me vertex and a point, that is what I'm going to use. So they give me h and k. This is my vertex. Up here, that high point of the graph, so this is h and k. Then they're giving me a random point, so I'm going to call that x and y. So I take all 4 of these numbers and I'm going to plug them into that formula up there. So y, I'm going to replace with y right here, which is -7. You're going to keep your a value because that's what you're going to solve for. And then you're plugging in x, which is 7, minus h, so -5 squared, plus k, so -6. Just plugging in these 4 numbers. Because what I'm going to do is I'm going to solve for a and plug it back into my equation along with the vertex for my final answer. So -7 is equal to a. 7 minus 5 is 2. Copy down the rest. 2 squared is going to give me 4. So I'm going to rewrite this as 4a because you don't write a4. You reorder it. Then I'm going to get a by itself by adding 6 to both sides. Then I'm going to divide by 4, and a is equal to -1/4. So another way you could say -1/4 is -0.25. So I know my a value is -0.25. So when I write my final answer, using again this formula, you plug in a. Then you plug in the vertex. When you plug in the vertex, we remember it's x minus h. So whatever your x value is here changes signs. So it's -5 squared, and then you just put the cape. So that is how I get my answer of B. Okay. Mike is studying the function f of x shown in the graph. He claims that he can transform this function to include the ordered pair -3, 4. So let's put that on our graph. -3, 4 is right here. So how did he get from here over here? So let's look and see what these mean. If I take my function and transform it f quantity x minus 3, this means, because the -3 is in parentheses, that I'm taking my function and I'm shifting it 3 to the right. So if I take my function and move it 3 to the right, that is not going to include that point. F of x with the -3 on the outside means translate 3 down. If I translate 3 down, that's not going to include that point. F of x plus 3 with the 3 on the outside of parentheses means go 3 up, translate 3 up, and that is not going to include this ordered pair. But if I look at this, which means plus 3 inside parentheses means translate 3 to the left, if I translate 3 to the left, that will include my parabola. So yes, D is my answer. Which expression represents this here? What we have is subtracting complex numbers. So what we're going to do is we're going to distribute that negative into these parentheses over here. So I have 5 plus 2i, and then negative times -2 is positive 2. Negative times positive I is negative I. So then what I do is I combine my real numbers, 5 and 2, to get 7, and then I combine my imaginary numbers. 2 minus 1i is positive I. So my answer is B, 7 plus I. Number 21, it might be helpful if you use the graph, but I'm not going to use the graph to do this. I'm just going to look at the words. So it says here that we want a vertical stretch by a factor of 3. So we remember the vertical stretch is going to be our A value. The A value is the number out in front. So far, all of these except for part D look good because we want a vertical stretch. So the number out front needs to be a 3. A reflection over the x-axis or in the x-axis makes your A value negative. So you already know your answer is C. And then they also say translating 3 units to the left, and that means, remember, you go in parentheses, so you change the sign. So we think -3, but we're actually going to be adding 3 in parentheses so that we can double check. So our answer is C because of the reflection. And then that would have -3, 0 as our vertex. And the reason why is because if this is our parent function, because it says translate 3 units to the left, that's why we would have a new vertex over here at -3, 0. Number 22, we're solving for y. So what I'm going to do is I'm going to eliminate x. So to eliminate x, I would want the same number top and bottom, one positive, one negative. So I want -6 on top to cancel out with 6x. So I'm going to start by multiplying the top by -6. So my top equation becomes -6x plus 12y, and that's equal to +6. And then I'm going to just recopy my second equation. Then I'm going to add down so that those cancel. 12y minus 3y is 9y, and that's equal to 36. Dividing by 9, y is equal to 4. Number 23, which of the following values are x coordinates of the solutions to the systems? So when we look for values of x, we're going to need to solve this. So we're going to use the substitution method. So for our substitution method, I'm going to create one equation. Because they're both equal to y, they're going to be equal to each other. So what I'm going to do is I'm going to take 2x minus 2 and substitute it in right here for y. Because they're both equal to y, they're equal to each other. So it's 2x minus 2 is equal to x squared minus 7x plus 12. So now what I'm going to do is I'm going to move everything to one side and I'm going to try to factor. Because factoring, again, is the easiest method we have for solving the quadratic. So we should try the factoring method, which means everything needs to be on one side. So I'm going to move over the 2x and move over the negative 2 to go on the right side of the equal sign. So to move the positive 2x, I'm going to subtract 2x to both sides. To move negative 2, I'm going to add 2 to both sides. So these cancel, and I have 0 equals x squared minus 9x plus 14. Okay, so now what I'm going to do is I'm going to factor this. So when I factor, hold on, I'm checking my work really quick, guys. Okay. When I factor this, I'm going to have x and x and 7 and 2. And I have negative 9x that this needs to add up to. So my factors both need to be negative. So I have x minus 7 is equal, or x minus 7 and x minus 2. So I remember that whenever I'm solving a system, I take each of the factors and I set them equal to 0. So when I solve, I get x equals 7, and I get x is equal to 2. Trying to check this for a second. Okay, I don't know why our answers aren't there, but it's 7 and 2 because they just asked us for the x coordinate, doesn't want the y, so it doesn't look like we're going to plug that back in. Maybe that's how they got their answers. No. Interesting. Okay, so those will be our answers, 7 and 2. Okay. Number 24 is asking which statements about the function are true. So we're actually looking at a lot of information in this problem. So we're going to circle all that apply. So given this parabola or this quadratic equation, they want to know if the parabola opens down. So for part A, what we look at for the parabola opening up or down is the A value. So the A value for this equation is positive 1. Since our A value is positive 1, that means that my graph is going to look like this. It's a positive parabola, positive graph, meaning it's going to open up. So my answer for A is not what I want. This parabola opens up. Part B is talking about x-intercepts, so we're going to need to find the x-intercepts, meaning we're going to solve this. Remember, x-intercepts means solve. So I'm going to write down that equation and I'm going to try to factor that. So I get x and x, 7 and 1, that are going to add up to positive 8x. X times 7 is 7x. 1 times x is 1x. Both of these signs need to be positive. My factors are x plus 7 and x plus 1. So now I take each of these, set it equal to 0. X is equal to negative 7 for my first x-intercept, and x is equal to negative 1 for my second x-intercept. So B is correct. Part C talks about the y-intercept. So the y-intercept of an equation is when x is equal to 0. So when x is equal to 0, that's where my graph is going to cross the y-axis. So if I substitute that in to my equation, it will give me 0 squared plus 8 times 0 plus 7. 0 squared is 0. 8 times 0 is 0 plus 7. So y is equal to 7. So yes, my y-intercept is 7. They're asking if the axis of symmetry is equal to -4. So there's different ways that we can look at this one. I'm going to go ahead and move my paper a little bit to the side. Part D, we are looking at the axis of symmetry. So the axis of symmetry is basically looking at the vertex. It's looking at the x value and the vertex. So what we can do is we can use the formula that says to find the vertex, you have x equals p plus q divided by 2, where p and q are x-intercepts. We already found our x-intercepts were -7 and -1. So you add the x-intercepts, divide by 2, -6 divided by, -8, -7 and -1 is -8. -8 divided by 2 is -4. So -4 is going to be our axis of symmetry. If you don't want to remember that formula, you can just visualize the graph. For this graph, I have x-intercepts at -1, and also over here at -7. So when you have your axis of symmetry, it's going to be what divides this graph right in half for our parabola. So what you can do is just count boxes to figure out what value is in the middle. So I find that this is going to be my line of symmetry, and that is at -1, -2, -3, -4. That's another way you can do it without the formula. So D is one of our answers. And then part E talks about the minimum value. So let me come up here. I know this is getting a little sloppy. So E talks about the minimum value, which refers to the vertex. Minimum refers to vertex. So minimum value means we're going to take the x and plug it back in to get your y. So it's your y value. So x is equal to -b over 2a, which we actually don't really need to do because we already know the x value. But just in case, -b over 2a would be -8 over 2 times a. So 2 times 1. Okay, so then you take that and you plug it back in, which, by the way, we knew that the axis of symmetry already, -4. But just in case, we can do that here, and then we plug back in to get that value. So the value is going to be the y value. So when I plug that into my equation, it's -4 squared plus 8 times -4 plus 7. -4 squared is 16. 8 times -4 is -32 plus 7. 16 minus 32 is -16. -16 plus 7, sorry, that's getting sloppy, is -9. So -9 is also a correct answer. That is the minimum value. That means on my graph, I have this parabola opening up. The vertex is going to be down here at -4, -9. So the minimum value is down here at -9. Lots of steps in number 24. Okay, number 25 gives us this graph, and it tells us it's representing x minus 1 squared minus 4. And we're going to look at each of these statements and figure if they're true or false. So, is the line of symmetry at x equals 4? So remember, the line of symmetry is what is basically dividing that U-shaped parabola directly in half. It's always going to include your vertex. So my line of symmetry is x equals 4. That's true. The maximum of g of x is less than the maximum of f of x. Okay, so let me rephrase what I said in the beginning. This graph is not graphed on here. The graph represents g of x. This is f of x that we're actually going to graph on here. So This is vertex form. If I want a graph, I have to first look at the vertex, which is at 1, -4. Remember, you take that value out, change the sign. So at 1, -4, I'm going to have my parabola. I'm going to do a quick sketch. This one is opening up because of the positive a value, which is a +1. And that positive a value tells me this is going to be a positive parabola. So I'm just doing a quick sketch, and I'm going to label that f of x. All right, now we're going to be able to answer the next question. The maximum of g of x is less than the maximum of f of x. So first of all, I think they meant to say minimum because these are minimums, not maximums on the value. So g of x has a minimum over here at -3, and then my minimum for f of x is at -4. So g of x is not less than, it's actually greater than. And let me write that down. So this ordered pair is 4, -3. This ordered pair is 1, -4. And we're going to actually look at their y values. Or you just see on the graph that f of x is below, so f of x is less, not g of x, so that's false. And then they ask us the value of x when f of x is at its minimum. They meant to say minimum again, you guys. Is less than the value of x of g of x when it's at its minimum. So what we're now looking at are the values of x in the vertex. So we're looking at 1 and 4. So the value of x, f of x, is less. So it is less than the 4. So this is true. So again, these questions are just asking us to kind of look at the vertices and compare the vertex for each of those. Okay. Number 26, we're going to solve by finding the square root. So remember, when you're using the square root method, you're trying to isolate x. So we're going to use our inverse operations to move everything away from this x right here. So the first thing I'm going to do is subtract 6 to both sides, and I get 3x squared is equal to 54. Then I divide both sides by 3, and x squared is equal to 54 divided by 3, which gives us 18. So x squared is equal to 18. My next step is to get rid of the square by doing the inverse operation for squaring, which is to do the square root. So I get x is equal to plus or minus square root of 18. We're not done. We don't want to leave our answer like this because we can actually simplify this. So I'm going to write down this list of perfect squares. This list that I'm about to write is the only way that we break down square roots. So the list starts with 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and it goes on. All of these are perfect squares, and those are the numbers you use to simplify square roots. So I look at 18. Can I divide out 4? No. Can I divide out 9? Yes. So what I'll do is I'll rewrite the square root of 18 as the square root of 9 times the square root of 2. And then you simplify. The square root of 9 is 3. Square root of 2 can't be simplified, so you just leave it. So you have two answers, positive 3 square root 2 and negative 3 square root 2. So don't forget, when you do square root, you always have plus or minus. Number 27, we're going to solve the quadratic equation by factoring. We like factoring. So remember, you factor and set your factors equal to 0. Don't forget to set them equal to 0. So when I factor this, it's going to be 3x and x, and then we're going to add up to negative 7x for my middle term. And then two numbers to multiply to 6 are going to be 2 and 3. So when I multiply diagonally, x times 2 is 2x, 3x times 3 is 9x. These signs need to be different to get us subtracting and getting to 7. You always keep the sign from the larger number, so the larger number needs to be negative. So the 2 is positive, carry over the 2 to the left, carry over negative, carry over positive to the left, carry over negative to the left, and we have our factors, 3x plus 2, x minus 3. So again, you take each of these factors and you set them equal to 0. So So 3x plus 2 equals 0, x minus 3 equals 0, and then we solve. Subtract 2 to both sides. Divide 3 to both sides. X is equal to negative 2/3 is my first answer. And then adding 3 to both sides, x equals 3. And that's how we would solve by factoring. Number 28, we're going to solve, or let's see, oh, not solve yet. Number 28, what is the real part of this product, whoops, sorry guys, of this product of complex numbers? So what I'm going to do is I'm going to first multiply that out. So we got to find the product first. And then we're going to simplify to figure out our real part of the complex number. So I'm going to distribute 9 over to these parentheses, then I'm going to distribute 2i. So when I distribute 9, 9 times 5 is 45. 9 times negative 6i is negative 54i. Then I'm going to distribute the 2i. 2i times 5 is positive 10i. 2i times negative 6 is negative 12i squared. So now I'm going to go through and I'm going to simplify. So I'm going to write down 45. Combine negative 54 and negative 10 to give us negative 44i. And then remember, I squared is equal to negative 1. So I'm going to replace I squared with negative 1. So I get positive 12. Remember, I squared is thrown away. I is no longer part of this term. Then I combine like terms. I combine my real parts. 45 plus 12 gives me 57. And to answer this question, we need to know that 57 is the real part and 44 is the imaginary part because of the I. So my answer for the real part is 57. All right, we are going to solve again by finding square roots. So again, we're trying to isolate x. So what we're going to do is we're going to move over the 3 by using inverse operations. Then we're going to divide by 2. And then we need to get rid of our parentheses squared. So we are going to do the square root to both sides of this equation. So the square root is going to cancel out the square in the parentheses to leave us with x minus 1. And that's equal to plus or minus square root of 27. Remember, we don't want to keep this as square root of 27 because it can be reduced. We, again, use the list. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, 25, and so on. Those are the numbers we want to use to reduce or simplify radicals. So I'm actually going to rewrite this square root 27 as the square root of 9 times the square root of 3. And then we're going to simplify that. Square root of 9 is 3. Square root of 3 we can't do anything to. So we rewrite this as x minus 1 is equal to plus or minus 3 square root 3. And then my last step is moving the 1 to the other side. And you put that number in front of the plus or minus. So it's 1 plus or minus 3 square root 3. Okay, number 30, we are going to, I know depending on what teacher you have, some of these on the last page are a little out of order. So you can find this on the page 8. It's just in a different order depending on what teacher you have. So we're going to complete the square to solve this one. So remember, for completing the square, you're going to be using the formula b divided by 2 squared. Okay, so I'm going to be adding that to both sides, but not yet because I first need to move over my constant. So to move over the positive 24, I'm going to subtract 24 to both sides. And now I'll have x squared plus 4x is equal to negative 24. Now what I'm going to do is use the formula b divided by 2 squared, and I'm going to add that to both sides of this. So using b divided by 2 squared, b is 4. 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So I'm going to be adding 4 to both sides of this equation. And it looks like this. And then I'm going to rewrite this as a square binomial. So to rewrite this as a square binomial, you could factor the left side and get x plus 2, x plus 2. But we do have a shortcut that says the number inside parentheses with x. You can simply take b and just divide by 2. So it's x plus 2 squared. Again, if I were to factor this left side, it would be x plus 2, x plus 2, which gives us x plus 2 squared. We're trying to make this a square so we can solve, and that's why we rewrite it as a square binomial. Negative 24 plus 4 is negative 20. And then we are going to get rid of the parentheses squared because our next step is to solve. So we're going to get rid of that by doing the square root to both sides, and I have x plus 2 is equal to plus or minus square root of negative 20. There's a lot going on in here. We have to remember that because of the negative underneath the square root, I take out I. This is an imaginary number. So I'm going to take out I, and then also I'm going to rewrite square root of 20 as the square root of 4 times the square root of 5, which becomes 2 square root 5. So I have x plus 2 is equal to plus or minus 2i square root 5. So again, the I is here because of the negative underneath the radical, and then I took out a 4, which simplified to be 2. And then my final step is to move over the 2. Whenever you move over that constant, you always write it first, followed by the plus or minus with that radical. We're so close. Only a couple more problems. Number 31, I'm going to graph. So this is going to be quite a bit of steps, quite a bit of work, and this is going to be something that we've got to know for our exam pretty well by this point. So what we're going to do first is we're going to identify the vertex, and when you're given standard form like this, to find the vertex again is the formula negative b over 2a. So from this equation, I have a is 2 and b is 8, so I'll use those. Negative b means negative 8 over 2 times 2, 2 times a. So I have negative 8 divided by 4. Negative 8 divided by 4 is negative 2. So I have the x value for my vertex. I'm going to plug that back in to get the y value. So I'm plugging in negative 2 for both x's in my equation. It's going to be 2 times negative 2 squared plus 8 times negative 2 plus 9. Order of operations, negative 2 squared is 4. And I'm going to copy down the rest. And then 2 times 4 is going to give me 8. I'll rewrite that over here. 8 times negative 2 is negative 16 plus 9. 8 minus 16 is negative 8. Negative 8 plus 9 is 1. So my vertex is negative 2, comma 1. So when I graph, I'm always going to create a table with x and y, and the vertex always goes in the center. You create the table with 5 slots. Vertex will always go in the center. So to create the rest of your table, you're going to fill out the x side by subtracting 1 again. We're going to add 1 and add 1 again. So when you're doing this, since the graph is symmetric for a parabola, I'm only going to plug in these 2 points. It's probably a good idea to do all 4 just to check your work, but I'm just going to do these 2 for the sake of time. I'm a little tired. Okay, so I'm going to plug in negative 1, and I'm going to actually do that over here. So when x is equal to negative 1, I'm going to plug that into my original equation. I have y is equal to 2 times negative 1 squared plus 8 times negative 1 plus 9. So negative 1 squared is going to give me positive 1. Positive 1 times 2 is just 2. 8 times negative 1 is negative 8. Bring down the plus 9. 2 minus 8 is negative 6. Negative 6 plus 9 is 3. So when you have x is negative 1, your y value is 3. Put that in my table. All right, now we're going to plug in x equals 0 from the table. And when I do that, I have 2 times 0 squared plus 8 times 0 plus 9. And a lot of you know the shortcut and already know the answer is 9. But the reason why is because this is 0 in your first term. 8 times 0 is 0 plus 9. So y equals 9 when x equals 0. So because this is quadratic and we are symmetric across the vertex, 1 to the right is going to be the same as 1 to the left. 2 to the right is the same as 2 to the left. And now I'm going to plot those ordered pairs. So negative 4, comma 9 would go here on my graph. Negative 3, comma 3. Negative 2, comma 1. Negative 1, comma 3, and 0, comma 9. And then we draw our parabola. So we're going to need 5 points to get our precise graph. This vertex is the minimum because it is the very low point of the graph. There's no maximum, there's no very high point because the arrows go up infinitely. It doesn't have a maximum, just a minimum. And this parabola, opens up. So that is how we would do number 31. Find the vertex, put it in the middle of the table, and then put in those values of x, plug them in to get your values of y. Last question, number 32. We are going to solve for x. This takes us back to the first lesson when we solved the equations. So we're going to try to get x all by itself. So first thing we're going to do is distribute the negative 2 into the parentheses. So I'll have 1, negative 2 times 5x is negative 10x. Negative 2 times negative 3 is positive 6, and we're going to copy down the rest. Then I'm going to combine like terms. I have positive 1 combining with positive 6 to give me 7. I'm going to copy down the rest. Then I'm going to move over the negative 8x by adding 8x to both sides. And then negative 10x and 8x is negative 2x. Subtract 7. 3 minus 7 is negative 4. Divide both sides by negative 2. X is equal to negative 4 divided by negative 2, which is positive 2. So you're always going to get rid of those parentheses first. You're going to combine like terms. You're going to move all your x terms to one side and all the regular numbers or constants to the other side. You use inverse operations and be very careful when you are working with your integers. All right, good work, you guys. That is all for our practice test. Good luck on your test. Make sure that you are practicing on any questions that you weren't able to do the first time on your own. Good luck, guys.